CFS Designer, Stacked Walls. CFS Designer now includes stacked walls, a powerful tool to input up to 8 stories of axial load-bearing steel stud construction. This video demonstrates basic steps for using the Stacked Walls tool, which can be used for either platform framing or ledger framing. Access the user's manual located on the Help toolbar. The manual was updated for CFS Designer 2.0 and contains information on the Stacked Walls feature. Select Stacked Walls from the Home toolbar to launch the Stacked Walls interface. The model graphic displays on the left and the input area on the right, which includes 4 different categorized input tabs. Hover over question marks to view additional information regarding an entry. Use the levels arrow to increase or decrease the required number of levels for the structure. A total of 8 levels are allowed. Enter the wall height for each level. Select the stud spacing. For most of the drop-down boxes in CFS Designer, either enter a unique value directly in the field or select from the list. Tributary length is also available for supported members. In most cases, supported members are either roof trusses or floor joists. This input value is critical for correctly calculating wall system axial load. Typically, cold-formed steel structures are ledger framed, where the wall stud below meets the floor line and the joist frames into the side of the stud, creating eccentricity on the stud. The default setting applies an extra end moment to the stud. The triangular moment diagram, produced by any eccentricity, is added to the parabolic moment diagram that results from wind and seismic transverse loads. In platform framing, the floor joist frames completely over the top of the supporting stud, and the floor above is framed on top of the floor joist. In this system, there is no extra moment applied from the eccentricity. Platform framing settings are available from the drop-down. The final 3 columns contain flexural and axial bracing settings. Select Manual to individually enter each level setting. Or select one setting if all bracing settings are identical for each level. Then enter a value or select a setting from the drop-down. From the Loads tab, dead, live, snow and wind loads are entered for each level. Main wind force resisting system and component and cladding wind loads are entered separately because they are treated differently when creating load combinations. Horizontal and vertical seismic coefficients are also available and are multiplied by dead load to determine seismic loads. CFS Designer will automatically accumulate load for each level and the levels above. This saves time and ensures accuracy for the designer. Check Apply Live Load Reduction if required. However, even when checked, live load reductions may not apply due to the small tributary areas that are common in light frame construction. Axial load redistribution each level is relevant only when the stud spacing is not consistent from level to level. If checked, axial loads from walls above are redistributed based on relative stud spacing. In this scenario, a distribution member will be required at the top of the wall. If unchecked, axial loads from studs above are assumed to be supported directly by studs below. Indicate if the top level is a floor or a roof. The graphic in the model area provides a visual indicator. If it is a roof, feels for roof snow and roof wind loads become available. There are 10 individual user-controlled load combinations. The default combinations are derived directly from the ASCE 7-10 and IBC 2012 codes. Load combinations involving wind are from the AISI S211-07/S1-12. Default load combinations can easily be modified for each of the various loads by changing the values in column fields. Changes instantly reflect in the member interaction calculation. To restore the load combinations to CFS Designer defaults, click Restore Defaults. Distortional buckling parameters are available for each level. Settings include flexural and axial capacity, as well as distortional buckling parameters if they vary from the typical bracing conditions. Once all settings are established, member design is controlled on the Member Settings panel. Select Level 1 and adjust the settings until the maximum interaction is less than 1.0. Repeat the process for all levels in the model. It is easy to see how quickly level designs can be achieved with CFS Designer. Several report options are available. Select a level from the model and select Interaction Details. The report includes only the selected level, with detailed information on the loads and interactions. Follow the same process to view the Section Properties report for each individual level. Selecting Summary Report compiles a report for the entire system. Similar to other modules in CFS Designer, the member summary is available by selecting the expander at the bottom of the input window and contains analysis and design information that is more detailed than in the model view.